In this lecture, we are going to be looking at stationarity in code. Specifically, we'll be applying the augmented Dickey-Fuller test to a variety of datasets, and we'll learn whether or not it actually fits our intuition about what is stationary and what is not. This lecture is going to walk you through a prepared Colab notebook, although a very good exercise, which I always recommend, is once you know how this is done, to try and recreate it yourself with as few references as possible. As always, you can check the lectures, how to code by yourself, and how to practice for a more in-depth discussion. If there's anything in this lecture you didn't understand, or you think I missed a step, or didn't explain why we were doing something, please use the Q&A to inquire. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. Okay, so let's start by importing pandas, numpy, matplotlib, and the function AD-Fuller from stats models. Next, we're going to download our airline passengers dataset. Next, we're going to load in our dataset using pd.readcsv. Next, we're going to plot our dataset. So this will help remind you that this dataset is not stationary. There's both a trend and a seasonal component to this data. Next, we're going to test out the AD-Fuller function on DF passengers. Okay, so as you can see, we get a big tuple of numbers. What do these numbers mean? Well, we can check the documentation for stats models. The two key pieces of information we are interested in are the test statistic and the p-value, more so the p-value. As you know, the test statistic is used to compute the p-value. Note that these are the first two return values in the tuple. So next we're going to write a little helper function called ADF. This will help us more easily check the results of the ADF test, rather than trying to interpret a tuple of numbers. This function takes in a series called x. Inside the function, we run the AD-Fuller function on x. Next, we print the test statistic and the p-value. As is typical, we'll use a significance threshold of 5%. If the p-value is significant, we'll print out stationary. Otherwise, we'll print out non-stationary. Okay, so let's test our function on the DF passengers column once again. As you can see, the p-value is quite large, and we do not reject the null hypothesis. In other words, we conclude that this time series is non-stationary. Hopefully, this is the result you anticipated. Next, let's test whether or not this function works for an actual stationary signal. So this will be IID noise sampled from the standard normal. Note that this signal is strong sense stationary because the entire distribution remains constant over time. Alright, and we get a very small p-value on the order of 10 to the minus 18. Therefore, we conclude that this signal is stationary as expected. Now, everyone knows about the normal distribution, but what if we try a more exotic distribution like the gamma? Again, theoretically, we know that this signal is strong sense stationary because the distribution does not change over time and each sample is IID. Okay, and we get another very small p-value on the order of 10 to the minus 16. Again, we conclude that this signal is stationary. And by the way, if you don't know what the gamma distribution is, I'd recommend plotting this time series and also plotting a histogram of these samples. The gamma is a very important distribution, especially in Bayesian machine learning. Next, we're going to take the log of the passengers column. We'll be making use of this over the next few experiments. So next, let's run our test on the log passengers column. Not surprisingly, the result is that it's still non-stationary. Next, let's difference the passengers column. Remember that this is what we would like to fit an ARIMA to. So if we plot the diff column, we see that the variance of the signal appears to increase over time. We can therefore guess that this signal is non-stationary. Alright, so let's run the ADF test on the first difference of the passengers column. Note that we have to drop NA because whenever we take the first difference, we always have one NA value in the first row. Okay, so again, we end up saying that the signal is non-stationary. But notice how close the p-value is to 5%. If you had set your significance threshold to a higher number, like 10%, you would have concluded that the above signal is stationary. Okay, so next, we're going to take the first difference of the log passengers. We'll store this in a column called diff log. If we plot diff log, we notice that unlike the first difference of the raw passengers, the variance here does not increase over time. Perhaps then, this signal is more stationary than just the raw first difference. Of course, we still have to run our test. So next we run the ADF test on the diff log column. Again, recall that we have to drop the NA values. Alright, so surprisingly, we get a higher p-value than we did when the variance was increasing. Okay, so this is a good opportunity to remember that we care about stock prices in this course. So let's download the SP500 CSV. Next, we're going to load in the S&P 500 CSV using pd.readcsv. We'll assign this data frame to a variable called stocks. Next, we do a stocks.head just to remind you of what's inside this data frame. As you can see, the final column is the name column, which can be used to filter out any particular stock ticker. Next, we're going to grab all the rows where the name is equal to Goog, and we're going to grab the close column. Next, we're going to take the log of the close column to get the log price. Next, we're going to take the first difference of the log price column to get the log return. Next, we're going to plot the log price as a time series. As you can see, there is a clear trend. Next, we're going to plot the log return. So this looks pretty stationary, although the variance does seem to increase in some places. Okay, so let's try the ADF test on the log price. As expected, we conclude that the log price is non-stationary. Next, let's run the ADF test on the log returns. So the log returns are so stationary that the p-value just gets rounded down to 0. Now just for good measure, let's test a different stock. Let's use our other favorite stock, Starbucks. Again, the same code to calculate the log price and the log return. Next, we plot the log price. Again, we see a pretty clear trend. Next, we plot the log return. Again, it looks pretty stationary, except that the variance seems to not be constant. Okay, so let's run the ADF test on the Starbucks log price. As expected, it's non-stationary. Next, let's run the ADF test on the Starbucks log return. Alright, so just like the Google log returns, the p-value is so small that it gets rounded down to 0. Therefore, we conclude that these log returns are stationary.